Good day, everyone. Welcome to Science 10 Lessons. I am your teacher, Ma'am Arlene P. Gamuza. In this video, we'll talk about the qualitative characteristics of images, and this will be the part 1 of this two-part video. I hope you will have fun and enjoy our session. At the end of this session, we should be able to predict the qualitative characteristics of images formed by plane and curved mirrors and lenses in terms of orientation, type, and magnification. Let us have first this warm-up activity. Fill in the blanks in the sentence. In the box above the paragraph are words corresponding on the properties and behavior of light that you will encounter in this module. You write your answer in a clean sheet of paper. I will give you 1 minute to answer each paragraph. Your time starts now. Okay, so let us check your answer. Light is a natural agent that stimulates sight and makes things possible. It is a type of energy known as electromagnetic radiation. It is given out by luminous objects such as the sun, light bulbs, and laser. It is made up of little packets of energy called photons. Light travels as a wave. But unlike sound waves, it does not need any material to carry its energy along. This means that light can travel through a vacuum, a completely airless space. Light travels out from their source in a straight line called rays. Okay, did you get it correct? Okay, so let's have another paragraph and I will give you another 1 minute to answer that paragraph. Okay, allow me to read the paragraph. Light behaves in a variety of ways when it comes in contact with water, air, and other matters. When light strikes matter, a part of light is absorbed into the matter and is transformed into heat energy. If the matter that the light strikes is a transparent material, the light component that was not absorbed within the material is transmitted through and exits through to the outer side of the material. If the surface of the material is smooth, a mirror for example, reflection occurs. But if the surface is irregular, having pits and protrusions, the light scatters. So, did you get a perfect score? Okay, it's all right. Let us try to look at the next demonstration for us to learn something new about light rays.
Hello scientific audience, how are you all? So today I am going to demonstrate the laws of reflection of light by using a laser, protractor, some basic stationery, plane mirror and the screen. So screen is nothing but a white background. So I had a small piece of cardboard on which, a small box on which I have attached a white A4 size paper. So this is going to act as our screen. Now what happens is, this is the mirror, and the first law states that incident ray, reflected ray and normal, they all lie on the same plane. So that can be easily demonstrated even without the use of the protractor. And you will understand why we are using protractor, because the second law states that the angle of incidence and the angle of reflection are same. So we need to prove that. So here I am going to use a red laser, right, in order to support my demonstration, and anything which you see in the mirror will be the reflection. We are supposed to concentrate on this white screen. Okay, so this is our incident ray. The incident ray is this one, which is seen over here, and you will see that the reflected ray will also be on this particular white screen. So this white screen is nothing but, you can consider this as y-axis, this as x-axis, and this will be z-axis towards us. So this white screen is nothing but xy plane, and the incident ray and the reflected ray would definitely be on the xy plane. And from here, if you draw the normal that separates both incident and reflected ray, you will see that all three will on the same plane here. So I'm shining the red laser from this side, and you can clearly see the incident ray and the reflected ray as well. So incident ray, this is the incident ray, that is the reflected ray, and the normal is here, and you can see that all three lie on the same plane. To have a better view, I have switched off the light in the room, and now this is very well visible that this is our incident ray, that is our reflected ray, and here is our normal. And this point where the laser light would strike on the mirror, that would be the point of incidence, right? Now unfortunately I doesn't have another stand so that I can hold this laser, so I am doing it by my hand. So the point of incidence may keep on changing, but hopefully the idea is you have understood. Okay, so we are good to go for the second law of reflection, that is angle of incidence is equal to the angle of reflection. And what I have done is, the same cardboard box on which I had fixed this A4 size paper, and now I have also fixed a protractor on this white A4 size paper so it doesn't move, with the help of a glue, right? Okay, now what my plan is, that this is my plane mirror, and this plane mirror I am going to arrange perpendicular to this plane of paper, correct? So I am going to put it somewhere here on the protractor, and I would make sure that this plane mirror is perpendicular to the plane of paper and along this line, right, like this. And now I would make sure that this mirror does not move, so I will hold this mirror rigidly. Now I will pass the incident ray through here, so it would strike the mirror and it will go somewhere like this. So this would be my target point. I am planning to incident the light at this point, exactly at the middle point over here. So that would become the point of incidence, and this would be the direction of my incident ray. So incident ray would pass from here, it would strike and it would go like this, right? And I would be passing through this 30 degree, right? So in this particular case, this is our point of incidence. So this is our incident ray. That is our point of incidence, and perpendicular to the mirror there is always a normal. So this is normal. So that is 30 degree, and the normal will always pass through 90 degree, because from here the perpendicular line passes through 90 degree. So this is our normal. So this angle is 60 degree. So I am making sure that the angle of incidence is 60 degree, because this is 30 degree, this is 90 degree. So the angle of incidence is 60 degree. So if I am passing a ray of light through 30 degree, I should get the ray of light from the other end also as 30 degree, right? So let us do that. Through this laser light again, I will pass the incident ray through 30 degree. So this is my incident ray. It is going to strike at the point, and after reflection, as you can see, it passes through the 30 degree only from the other side. This is 30 degree and this is the same point, and look, this is the reflected ray that is on the same 30 degree on the other side. You can see here this is 30 degree. So your attention should be over here, correct? Have a look at it once again. I am passing the incident ray from 30 degree. It strikes exactly at the point that we decided. And there you see, it passes from the 30 degree mark only. So that means the reflected ray is on the other side of the normal, and the angle of incidence and angle of reflection are the same. So hopefully guys, you have understood this demonstration.
From that demonstration, we learned two things. The law of reflection states that first, the incident ray, reflected ray, and the normal line lie on the same place. So here it is. This is the normal line, this is the incident ray, and this is the reflected ray. They all lie in a point we call the point of reflection. The angle of incidence is equal to the angle of reflection with respect to the normal line. So the angle of incidence here is equal to the angle of reflection. That's according to law of reflection. Meron tayong dalawang uri ng reflection. We have specular or regular reflection and diffuse or irregular reflection. So when does it happen? So pag regular reflection, nangyayari siya when you have a smooth surface. So like this one. So you have a mountain, you have buildings and trees on the other side of the lake. So it is perfectly reflected in this very smooth surface of water. You see, the light, in this case, we have the sun as our source of light, is reflected at a definite angle. Ayan. So it leads in the formation of a very defined image, okay, of an object. While in diffuse or irregular reflection, the light scatters at it hits the reflective surface. So dito, you have a disturbed body of water, which ang tendency, it forms a distorted image of the object. Yan. So hindi masyadong maklaro yung image ng mountain, building, and trees, because light that are reflected scatters in all directions. Now, let's have a demonstration about convex and concave mirror. Okay, let's see the differences between the two spherical or curved mirrors.
The learning intention for this lesson is that you will understand how light is reflected off concave and convex mirrors, and the success criteria is that you will be able to define the terms convex and concave and draw scientific diagrams to demonstrate the reflection of light off a convex and a concave mirror. Here I've got a round mirror. Now both sides of this have been mirrored, and if the light is going to hit the inside of here, we say this is the concave surface. So it's a concave surface. I remember this as though, like, if you're walking into the cave, it's concave. The other way, if the light was to hit on the outside, this we call convex. So concave, walking into the cave, the light is going to go into the cave. Convex, it's going to hit the outside. Okay, now the way the light behaves with a concave mirror is that it will actually focus into a specific point. So the light, you can see it there, it's traveling in straight lines. I've used the triple beam here just so we can see how it's behaving. So we've got 3 beams that are going to hit the mirror, and they're going to get reflected towards one another to create what we call a focal point or a focus. Okay, so you can see that point here. Alright, see how all of those 3 beams, they all focus onto the same point after being reflected off that curved mirror. And the way that we would draw this is exactly the same as all the other ways. Okay, so you would trace the inside of your mirror, trace where the light box is, mark where the 3 rays are exiting the light box, mark where they hit the mirror, and the extra bit you would be labeling is marking where the focal point is, and then connecting up your lines so that you can see that. Now, if we're looking at a convex mirror, here the complete opposite happens. So instead of the rays being focused towards one another, and we end up with a focal point, this actually causes the light to disperse. So you can see that as the light hits the mirror, those beams are moving outwards, not towards one another.
Let's take note of the physical difference between the 2 spherical mirrors, the convex and the concave mirror. So you see that convex mirror are curved outward, okay, just like here the back of the spoon, and the concave mirror is curved inward. Okay, yung loob ng spoon natin, that represents a concave mirror. There are 2 types of images formed in spherical reflecting surfaces, the real image and then the virtual image. Real image is formed when light actually meet after reflection. It could be formed on screen and inverted with respect to the object. For example, in concave mirror, so it has a reflecting surface that is inward. So remember dun sa demonstration kanina, as the concave mirror is hit by light rays, the light rays are reflected and diverge in front of the mirror. They meet actually yung mga light rays. While in convex mirror, okay, the light rays do not actually intersect after reflection. So nagda-diverge sila. That's why convex mirror is also called as diverging mirror. Kasi they go in different direction, no, yung light rays. But then, when you trace the diverging light rays, when you try to trace it backward, you could see that the light rays virtually intersect at a certain point dun behind the mirror and form virtual image, which is smaller than the object, but then it is erect, no? It forms erect object, so behind the mirror. Bakit behind? Because they don't intersect in front, but virtually they intersect behind the mirror. So dun sa convex mirror, diverging mirror. Where concave mirror, kasi nag-intersect yung mga light in front, so it is also called as converging mirror. To describe the image formed in mirrors, we could use their location, orientation, size, or type. Okay, so in terms of location, we could check if the image is formed in front of the mirror or behind. For orientation, whether it is upright or inverted, we can say that the image is upright when the image is formed above the principal axis, and inverted when the image is formed below the principal axis. Then for the size, the object could have the same size with the image, or the image could have a smaller size or bigger size than the object. For the type, the image could be virtual or real. So recall, when we say virtual image, so the light rays do not actually intersect. Okay, they only virtually intersect. When we say real image, the light rays actually converge or intersect at a certain point. Let us take this as an example. So we have here an object placed in front of the mirror. So you have the light rays here reflecting in front of the mirror, and you have here the image that it forms. So let us try to describe the image in terms of each location, orientation, size, and type. So where can we find the image? So it is behind the mirror. Its orientation is upright because it is above the principal axis, and it has the same size with the object. Then it is virtual because the light rays do not actually intersect from behind. Okay, we only extended the reflecting rays, no, papunta doon sa likod, and we see that the light rays virtually intersect at this certain point. Okay, so the image is virtual. Okay, we will try to elaborate on this as we go on with our slide. Okay, we use rays and lines to locate and describe image formed in curved mirrors. For curved mirrors or spherical mirrors, we have points to remember. Okay, for example, in this one, what kind of mirror is this? Okay, right. This is a concave mirror. So you see we have 3 points here. Okay, so first we have the center of curvature. So how could we determine the center of curvature? So supposing ito yung ikumpletuhin natin yung part ng circle na ito. So yung pinaka center niya, that is the center of curvature. So another one, we have the focal point. So yung focal point, ayan, okay, just halfway siya between the vertex and center of curvature. Then we have our focal length, okay, yung distance between the vertex and the focal point. And then the radius of curvature is the distance from the vertex papunta doon sa center of curvature. And then the line where all the points lie is called the principal axis. Okay, so this is a convex mirror. So let's locate the points in the convex mirror. So assume natin that this is a complete circle. So we have the vertex, yung pinaka physical center ng mirror natin. Then the center of curvature, yung pinaka gitna ng circle. Then we have halfway between center of curvature and the vertex is the focal point. Okay, imagine natin that, or assume natin that there is an object in front of this convex mirror. So let's try to locate and describe kung ano yung image na ma-form sa mirror na yan. Okay, we will try to use this useful rays. So lalagyan natin ng name yung rays natin para mas madali nating maalala. Okay, so first we have the PF ray. So it means that P, gagawa tayo ng parallel line. Then F, that ray will be passing through the focal point. Okay, so first you have to draw a ray from the tip of the object papunta dun sa reflective surface na ating convex mirror. Then, a light ray that is passing through the focal point. So, bakit broken line yan? So, kasi mirror yan siya, hindi makalusot yung light natin. So, we will assume that this particular light ray is virtually passing through that point. So, yung actual ray will be reflected at a certain angle. And then, another is, we have the PF ray. So, a light ray from the tip of the object directed towards the focal point. Okay. Then, pagdating doon sa reflective surface, yung point na yan, so you have to draw a parallel line which will make it a FP ray. So, F ray directed to the focal point and then parallel ray. Okay. Another, we have the CC ray. So, a light ray drawn from the tip of the object directed towards the center of curvature. Then, that light ray will be reflected back to its way. So, where can we find the image? So, yung area kung saan nag-intersect yung mga light rays na yan is the location of the image. To describe the image, we could use the laws: location, orientation, size, and type of the object. So, saan makikita yung object? Okay, nasa likod. So, the location is behind the mirror. Or pwede rin natin sabihin na between the vertex and the focal point. Orientation niya, it is erect kasi nasa taas siya ng principal axis. Then, for the size, so compare natin yung size ng image sa ng object natin. Our image is smaller than our object. Then, for the type, it is virtual. Kasi bakit? The light rays are assumed to be intersecting at a certain point. So, it is a virtual. Another example is in this concave mirror. So, we will try to trace the path of the light ray hitting this particular spherical mirror. So, we will still use the three useful ray that we have, the PF ray, FP ray, and then the CC ray. So, assume natin that we have an object just before the center of curvature. So, ano yung unang gagawin natin? Okay, gagawa tayo ng PF ray. Okay, PF ray, parallel line from the tip of the object papunta sa mirror, and then from this reflecting surface passing through the focal point. So, here it is. Okay, so did you get that? So, bakit hindi siya broken line? Kasi nag-reflect siya in front of the mirror. Kasi yung points natin nasa harapan. Okay, another one, we have the FP ray. So, from the tip of the object, the ray will pass through the focal point until it hits the mirror, and then gagawa tayo ng P or parallel ray. Okay. Okay. I hope you get that. Okay, another one, you have the CC ray. So, from the tip of the object, dadaan sa center of curvature, then babalik sa kanyang original na path. Okay. Okay, that one. So, did you get that? So, you see, these rays have intersected in this particular point. Okay. So, what will be the image that will be formed? So, we will try to describe it. So, in terms of location, size, orientation, and type. So, for the location, the image will be located in front of the mirror between the C and F. Orientation niya, it is inverted. Okay, kasi nasa baba siya ng ating ng principal axis. And then, for the size, compare nyo dun sa object natin, our image is smaller than our object. Then, for the type, it is real. Kasi bakit? Because the light rays actually intersect at a certain point. So these are actual rays. So it forms real image. Okay, so I hope you get that. Okay, nakuha ba yon? So, bibigyan nyo kayo ng another example. So this time, kayo naman yung gagawa in your sheet of paper. I will give you 2 minutes to do this and then we will check your output. Okay, you try this one. Our object is located between the center of curvature and then the focal point. Okay, still you may use the 3 useful rays. Okay, your timer starts now. Okay, time's up. If our timer is still running. So anyways, okay, let us try to check your output. Okay, so first you have to draw the PF ray from the tip of the object papunta sa surface ng mirror and then passing through the focal point. And then for FP ray, we have a light ray from the tip of the object passing through the focal point and then a parallel line. Then CC ray natin from the tip of the object papunta sa center of curvature. But this time, kasi hindi siya mag-hit doon sa reflective surface na ating mirror. So, pwede natin siyang hindi ilagay. So, we could see that the FP ray and the P ray have intersected in a certain point. Then we could say that our image could be formed in this particular point. Okay, let us describe this image. So, location niya, it is in front of the mirror. Orientation niya is inverted kasi nasa baba siya na ating principal axis. Size, it has the same size with our object. And it is real kasi the light rays are actually intersecting at this certain point. Okay, nakuha na ninyo? Okay, so practice makes perfect. So, sa mga medyo alanganin pa, pwede nyo ulit-ulitin itong video na ito para ma-master ninyo kung paano gawin yung ating ray diagram. And don't forget our useful rays para mas madali natin ma-identify or ma-draw yung ating rays at as we trace the path of light before hitting the mirror. So this is just to give us a general picture of where and what type of image will be formed in spherical mirror. So for concave mirror, when you have an object placed before the center of curvature, its location could be between the center of curvature and then the focal point. It is inverted and reduced in size and real. Okay, because the light rays again in concave mirrors actually meet at a certain point. Okay, when you have an object placed at the center of curvature, the image will also be located at the center of curvature, but then it will still be inverted, but it will have the same size as the object and real. Then when you have an object placed at the focal point in front of this concave mirror, there could be no image formed because of the proximity of the object to the mirror. Another, in convex mirror, kahit saan mo ilagay yung iyong object in front of this convex mirror, you will always find that the image will be formed behind the mirror, and then it is always upright, but always reduced and always vertical. Okay, so that ends our part 1. So I hope by this time, you are able to locate and describe the image which could be formed in plane and spherical mirrors. Okay, see you again in our part 2.